Hey everyone. So today's lesson, 4.3, equivalent trigonometric expressions, we are going to go through most of this. We are going to leave the very last couple of questions, that's sort of like T-style questions for maybe Monday. But yeah, the goal is to understand conceptually what this equivalent trig expression is and know where it's coming from and what we're actually doing so that you don't have to memorize this. Like that's 6 per quadrant. There are 4, so 24 of these. Do you really want to memorize it? I really hope not. And so let's really try to understand what this equivalent stuff is. Really pay attention to it with an open mind, not like trying to memorize, but just, yeah, try to chew on it a little bit over the weekend. Okay? There is an expectation. Before you get to 4.3, you must have your CAS rule down. In other words, you know exactly when something becomes a negative when you do a conversion, and when you leave it as a positive, okay, depending on what quadrant it is. All right, so let's get started. If, for example, for using regular CAS rule, if I said it was sine 150, you would know that it is an angle that goes into the second quadrant. And so the acute related angle right here with respect to the x-axis would be 30 degrees. And CAST, sine 30 is the same as sine 150 is the same as sine 30, and you can solve this using your special triangles or the chart method that I think I showed you before, which would be, let's see, 1 over 2. All right? And in the same way, if you had sine 120, sine 120 dives into the third quadrant, and that creates an angle of 30 with respect to the x-axis once again. So this would be sine 30, except because it's the third quadrant, that's got to be a negative, so the answer is negative 120. Okay, so I know you can go from sine to sine, right? Changing a large angle into a smaller, manageable angle, and watching out for whether it's a positive or negative depending on which quadrant it goes. Today's lesson is a little different. Today's lesson takes a ratio and asks you to rewrite it with its correlated ratio, right? So like, for example, why do we have this thing called sine and cosine? Why do we have this thing called secant and cosecant? Why do I have this thing called cosine, secant versus cosecant, and why do I have this thing called tangent and then cotangent? There's actually a relationship between these two and why they sound very similar, except we stick a co in front, and that is covered today. Your goal is to take a look at an angle with a given ratio and turn it into its correlated ratio, which will inevitably change the angle you're dealing with. That's it. That's the end game. Okay? So even if you don't understand how to do it, understand what we're trying to do, and that is if I give you some ratio, you're going to write it into its correlated ratio. Okay? If I give you cosine, you turn it into its sine. If I give you a secant, you can write it as a cosecant. If I give you a cotangent, you could rewrite it with its correlated ratio, which is tangent. Okay, so sine to cosine and vice versa, secant to cosecant and vice versa, tangent to cotangent and vice versa. Okay, that is today. So let's take a look at how they are related. There is a rational, logical connection between the two, but it all starts with understanding this. You ready? Okay. I hope you're following so far. Given a special point, any point at all, let's pretend I have a point right here, and the horizontal distance from the origin is x, and the vertical distance from the origin would be y. Okay? That would be a y. And so this point, I think it's fair to say, is the point x, comma, y. Okay? So from the angle A, or alpha, whatever you want to call it, let's call it A, which of these three, x, y, and r for radius, right, or the horizontal, or the hypotenuse, which is the adjacent side? 1, 2, 3. It's the x value, because, you know, if this is my angle, x is adjacent to that angle. What's the side opposite to the angle? Ready? 1, 2, 3. It's the y side. Good. And the hypotenuse would be r. No biggie. Now I want to introduce you to its correlated angle. So think about it. This is a triangle. Let's pretend this is a 30. And that obviously is 90 degrees. What is this angle going to be? Going once, going twice. It should be 60 degrees. Well, how do we know that? We know that the angles within a triangle add to 180. Take away 90 leaves you 90. So 30 plus something has to be 90, and I know it's going to be 60. Okay? 30 and 60 are complementary angles. So alpha and beta are complementary. And that is a grade 9 term. It basically means they add to 90 degrees. Right? So here's two angles. If that's A and that's B, they add to 90 degrees. So it's not a big thing. You don't have to memorize the word complementary if you didn't know it. But the reason I bring it up is because instead of calling it complementary in this situation, we're just going to say that they are correlated. They are correlated because they add up to 90, and they're special when I place it in a 90 degree a right angle triangle. Okay? So instead of making the correlated angle 60 here, I'm going to do something a little different. I am going to turn this line into a rectangle, which means the height is y and the length is x. If my angle A is 30 degrees, what would you say this complementary angle here would be? Same as B, it would be 60. So instead of writing angles this time, I just use the numbers because it would help us understand. Instead of writing numbers, you can say that this complementary angle will be angle B. So the correlated angle, I could say, instead of trying to create a right angle triangle, I could say if angle A is with respect to the x-axis, angle B is with respect to the y-axis. Okay, that's a little bit of a special trait. I'm going to come back to this. But anyways, let's look at the correlated angle B. If this is my angle, what's my adjacent side? Going once, going twice. It's going to be the side that's right next to it. It's y. For my correlated angle, what's my opposite side? The side furthest from the angle. It would be x. And the hypotenuse, it would still be r. So why am I stating this? It may seem obvious to you, but I need you to recognize that the adjacent side has been matched with the opposite side depending on what angle it is. Okay? And the opposite side y for angle A happens to be the same as the adjacent side for angle B. In other words, what am I trying to say? Take a look. Sine of angle A is opposite over hypotenuse, which is opposite over hypotenuse. Whereas here, if I want the same thing, y over r, take a look what happens. Cosine of angle B is adjacent over hypotenuse, which is what? For angle B, adjacent is y over r. What did I just show? Sine of angle A gives me the same ratio as cosine of angle B. If you were very observant when you first learned sine and cosine in grade 10, you might have made this connection already. Okay, like I gave you an angle that's like 45 and 45. You might have thought, oh, this and this, and this is the same. And if I gave you something like 30 and 60, you're like, oh, this to this for sine is the same as this to this for cosine. Okay, you might have made that observation connection already. If that's the case, then amazing, you're sort of ahead. This connection, I'm going to ask myself, does that happen all the time? Is this in fact true every single time? The short answer, yes, but I'm gonna get you to explore yourself. Okay, so with your desk mate, I'm gonna ask you to do something. So this is the idea that if you have sine A equals cosine B, sine A is the same as whatever my angle is subtracted from 90 is B. Okay, so you'll get a chance to see where I'm getting with this. But I want you to observe. Okay, so you and a friend are going to choose between column 1 and column 2. So one partner takes column 1, the other partner takes column 2. If you're in a group of 3, whatever, at least one person takes column 1, the other person takes column 2, right? I'd like you to take your calculator, set it to degrees, and solve. One partner gets this answer, the other partner gets this answer, and notice 20, 70, they are a sum of 90. You should get the same answer. I want you to complete this. Okay, I'll give you like, I don't know, the substitute teacher can pause this for a second, and if you can give the class maybe 5 minutes so that they complete all of this up until the last one, and all of this up until the last one, and then we'll go through the remaining bits together. Okay? Okay, so I'm gonna assume the substitute did pause for you, and we can continue on with everyone giving this a shot. Okay, so what you would have noticed is there is a relationship 20, 70, sine and cosine, the answers are the same. 35, 55, they add to 90, cosine and its related ratio sine, the answers are the same. 25, 65, they add to 90, tan, cotan, the related ratio, the answers are the same. Okay, and it keeps going. Secant, cosecant, 61 plus 29, that's 90. So we can establish if I have some angle, so in this case, tangent, right? Tangent of 90 minus 50, tangent of 25, which is the same as 90 minus 65, is equal to the number that we subtracted from 90, cotangent of 65. Cotangent 90 minus 14, I know the angle is 76, but the angle that we are subtracting from 90, it's right here. They are the same. And same thing here. I know the angle is 61, but the angle we subtract from the 90, in other words, the correlated angle of 61 is 29. 29. So the angle that we're actually putting in to say that they are equivalent expressions, this angle, you can also say is the angle we make with the y-axis. So once again, if this was 30, the angle with the y-axis is 60. If this angle is 45, the angle we make with the y-axis is 45. If this was 1 degrees, the angle we make with the y-axis would be 89. They are correlated angles. Okay? I feel like I've drilled it in enough. So let's keep going. So the idea is this. What do we do? How can we sort of get around this without thinking too hard? Me specifically, because I don't want to memorize this, I always actually draw my axes, and then I draw the angle that I'm dealing with. And normally for cast rule, I look at this angle. But if I want to convert it to its correlated angle, or correlated ratio, I calculate the angle that it makes with the y-axis, and then just convert. Let's try some practice. Okay, we're still dealing with quadrant 1, just until people get the hang of it. So here we go. So this is A, B, C. I wrote A, B, C, so we have some space. I don't know why I doubled it. Don't ask. But let's try this. Okay. Sine. For the sake of you making sense of this, I'm gonna do this one time only. I'm gonna write this as angles, but you need to get used to radians as soon as possible. And yes, the quiz is still on. Okay, here we go. This is like saying sine of 30, right? So if I convert sine into its co-ratio, what is a correlated angle of 30? It would be 60. So instead what you can say is, oh, every time I just basically have to take an angle and turn it into 90 minus something. That something is what I copy down. I don't like that mindset because it leaves room for a lot of careless errors, in my opinion. But that is one way you can think about it. I actually don't do this. What I do is, okay, what is this angle? That is sine 30. Okay, sine 30, sine 30. Sine 30 is right here. The correlated angle that is made with the y-axis is 60. Great. So if it's sine 30, the correlated angle is 60, and the co-ratio of sine would be cos. Done. That's how I do it. Okay, and because it's quadrant 1, I don't have to worry about any signs. Let's try this again. Oh, by the way, if you do ask other teachers, they might actually go about this a different way too. Because you are dealing with 90 degrees, another thing that some teachers do is, because this is 30, they might show you that a correlated angle is basically an angle that is rotated 90 degrees. And when you rotate 90 degrees, what is the angle you make with the x-axis? Think about it. Think about it. If you rotate this 90 degrees, this 30 can be found here, which means my angle is 60 once again. So it's basically the same stuff. But as opposed to rotating 90 degrees and getting you to work with your spatial visual, I'm going to ask you to start off your journey by saying we are making an angle with the y-axis as your correlated instead. Okay? So if you didn't get that at all, don't worry about it. Okay? You can ask me again on Monday. For now, let's try this again. Cos of 90, once again, cos of 90 minus pi over 4, that's 45 degrees, okay, is like saying, what is the correlated, what is a equivalent trigonometric expression for cosine 45? In my head, what I do is, okay, if this is 45, what angle do I make with the y-axis? Oh, that's 45. So the correlated angle for cos 45 is 45. And the co-ratio, or correlated, trigonometric ratio for cosine is just sine. And because this is quadrant 1, once again, I don't have to worry about any plus or minus. Everything is a positive value. Let's do one more. Tangent. Okay, this is 90 degrees minus 30 degrees. In other words, what is the correlated, or equivalent trigonometric expression for tan 60? All right, well, 60 is about there. The angle that I make with the y-axis is 30, so the correlated angle would be 30 degrees. What is the co-ratio for tangent? It would be co-tan. They are equivalent. That's it. So again, you start to see it. The angle that we are subtracting from the 90, it's always that answer. Again, that might change a little bit once we get to quadrant 2. So you might be thinking, all right, every time you keep mentioning these questions, getting these answers, you always say it's in quadrant 1, so I don't have to worry. What if it isn't in quadrant 1? Well, let's take a look at this chart. If we were dealing with normal cast rule, C-A-S-T, right? All of these are positive, yes. Only the sine ratio remained positive when we wrote a equivalent expression, okay, for cast rule. Here, only tangent remained positive when I wrote a equivalent tangent, and only cosine remained positive when I wrote a equivalent cosine, okay? The rules for correlated ratios or equivalent trigonometric ratios using correlated angles is if the question is given as sine or 1 over sine, the correlated ratio is left as positive. So if it give it to you as sine of, let's pretend it's 120 degrees, okay? If I give you an angle of 120 degrees, right? This is going to be converted into positive cosine. If I give you cosecant, which is 1 over sine of, let's say, 120 degrees, that conversion is going to be positive. Anything else will be negative. Anything else will be negative. The same applies for tangent. If I give you tangent or 1 over tangent, which is cotangent, the correlated ratio remains positive. Any other ratios that I give you, the correlated ratio is going to be negative. Same with cosine. If cos or secant, which is 1 over cos, is given to you as its original question with a very large angle, its correlated is going to be positive. Anything else, like sine or tangent, when I do its correlated ratio, it's going to be negative. If I do cosecant, cotangent, its correlated ratio is going to be negative. Okay, so the main point is, if I give you some random angle, look for its correlated angle that is with respect to the y-axis. And 2, make sure, depending on what quadrant it is, that you stick a negative in there correctly or not. So let's do an example, okay? I'm going to draw this out. So once again, just so you understand where we're going with this, I'm going to write this in degrees. Okay, sacrilege. Ms. Malloy is going to be upset with me, but just for now. Okay, so you can copy and paste this into the formulas that I give you and get the right answer, but I don't want you to memorize this. In fact, if you look at our formula sheet that you get, I don't give you all 24. I think I actually only give you these from quadrant 1 and quadrant 2. Okay, so it's better that you understand how it works. Let's do this. So this question says, okay, this is sine of 210. What is its correlated ratio? Here's how I do it. Step 1, figure out what the angle is with respect to the y-axis. So 210 is here. Okay, it's in quadrant 3, where CAST, it is the realm of tangents and cotangents. So what is the angle with respect to x? Well, you should know that's a 30. But forget that. I'm doing a equivalent trigonometric expression of its correlated. So what is the angle that you make with the y-axis? Right? I just wrote 30, so you should be able to tell me that the angle I make with the y-axis is 60. Okay. Next, what is the correlated ratio of sine? It would be cosine. Lastly, what quadrant is it? It's in quadrant 3. The only ratio that remains positive when it's asked of me is tangent or cotangent. This was given as sine, therefore this must be negative cosine. Yeah? Let's try it again. Cosine. I'm going to write it as a degree. Ms. Malloy is going to kill me. This is 90 degrees plus 45. So the original question is, if I ask you for cosine of 135, can you rewrite this as a different equivalent trigonometric expression? And I say, yeah. Let's figure out where we are. 135 is right here. It's in quadrant 2. Okay. What angle does this make, not with the x-axis, but what does it make with the y-axis? 135 minus 90 degrees. The correlated angle is equivalent to 45 degrees right there. And what is its correlated ratio? Cosine, sine. Bam. Lastly, C-A-S-T. Okay, pop quiz. The final answer is sine. Is the answer positive or negative? I'll give you 5, 4, 3, 2, 1. The answer is negative. It is a negative. Okay, why? The question given with the original angle is cosine. It is not sine or cosecant. Right? The only ones that will remain is if I give you an original question with sine or an original question with cosecant. You think about it like that. Okay? Let's do it one more time. Tangent. Sorry. I don't think I actually answered the question. We'll do that at the very end. I just need to make sure everyone understands. So this is, once again, sorry, Miss Malloy, this is 270 degrees plus 30. So the question is, what is an equivalent trigonometric expression using 300 degrees? Well, let's do it again. 300 degrees, this would be right here, because 3 quadrants gives me 270, plus a little bit extra gives me 300. 270 plus what is 300? You guessed it. The angle that I make with the y-axis is 30 degrees. So I write 30. All right. Next, what's the correlated ratio of tangent? Tangent, cotangent. No biggie. Now, C, A, S, T. This is the fourth quadrant, which means cosine of some big angle or secant of some big angle will remain as positive. Take a look, see? Cosecant remains positive, secant remains positive. Tangent is not one of those, and therefore the final answer will be a negative. Okay? I feel like I was clear enough, but there's always going to be some questions. Your goal for 4.3 is to be really comfortable taking any of these kinds of K-style questions and then converting. Okay? Why is it important? Because if you can do this, you don't need any calculators. Look, you already know, using special triangles, what cosine of 60 is. That would be 1 over 2. So sine of 210 is the same as negative cosine of 60, which is also the same as negative half. Sine 45, you already know, that's root 2 over 2. And negative cotangent of 30. I actually don't know that off the top of my head. That will have to be, oh geez. Triangle, if that's 30, that's 60, that's 1, 2, root 3. Nope, 1, 2, and root 3. That's my bad. 30, opposite over adjacent, so root 3 over 1. Oof, I hope I'm right on camera. You know what? I can't. I gotta do this again. Special triangles, right? That's 30, that's 60, that's a 1, 2, that has to be a root 3 to make this work. Tangent 30 is 1 over root thing, so 1 over tangent of 30 is root 3 over 1. Yeah, that makes sense. Okay, and that's today's lesson. It was a little long, but I really hope you got something out of it. Don't worry about practice 3. It's sort of like a A/T question that we can do on Monday after our quiz. Okay? For the rest of class today, I'd like you to take a look at the textbook. Hopefully you have something. If not, ask the substitute to take a picture of the textbooks that are behind the black file cabinet at the front of the classroom. Okay, take a quick photo and get started. Okay, do as many of these as you can, because it's really not a conceptual thing at a certain point in time. It might be hard at first, but I need you to be able to not hesitate when you see something like this. Okay? Normally I would say any questions, but I don't see you there. So work hard, suffer well, and I expect emails to be sent my way if you still have some trouble with this over the weekend. Okay? Your priority obviously is your quiz on Monday, which ensures that you really know your radians, so you don't have to do this anymore, that you're comfortable with radians and pies and whatever. Yeah, if you need me, email me. Otherwise, use each other. Okay, butt heads, throw ideas around, and I hope all of you will find success come Monday. Okay, best of luck. We will see you next week.